either a combination of lectures or tutorials. So I want to introduce you to Dorota, who would be your tutor on Monday morning if I'm not teaching. And the idea is that I would upload some activity for the days that there are no lectures on Monday morning. And you would be able to practice through the tools that you have hopefully learned to look through the lectures, and you do the exercises. The other thing I wanted to tell you about logistics is I have now got more or less everybody put in the groups. Clearly, I did put you a deadline till last Friday, and majority of you have actually formed your own groups, which I'm going to put that on the module website, so you can go and have a look and see which teams you are with. Obviously, if you have already, of course, your team members, you know who's going to be there. But it might be one or two cases I had to shift one person from one group to another because majority of the groups are fine, but because we are 99, obviously I needed to do a bit of juggling. So if there's an issue, you can speak to me, but I try to put that primarily for the people who have not shown any interest which group they want to join to. Okay, with too much of ado, I would like to introduce my two lecturers for today. Well, I don't know how this thing is going to move on. We have got this week and next week, but can I introduce you Chris Gutteridge, who is really the personality of Open Data at Southampton University, and can I introduce you also to Dr. Ash Smith,
who does the actual work.
So I'm really, really excited because last year, when these two guys were doing the lectures, I was swishing down the Swiss Alps skiing. So this year, I made an effort to actually contribute myself into doing the exercises that you're doing. So, yes, now I'm going to sit back and listen like the rest of you to this wonderful lecture.
Hi everyone. Okay, so I'm Chris Gutteridge. I was an ECS undergraduate student who graduated in 1997 and got a job doing this web thing. That kind of got fashionable. Then later on, I did this open data thing. I kind of stick to the up and coming fashion. I think smart campuses. I'm not sure. Ash and I both work in Life Solutions Web and Data Innovation and Development team, which sounds quite good. Web and Web and Data Innovation and Development. It's sticking on boxes. And it's actually quite good that the university has a team like that and then recognises its worth. Even though we've been moved to centralised solutions and we work at the university, we still need to do cool ECS experimental stuff to help try out some of the ideas that come from ECS, try and work them into business as usual. That email address is out of date. I've given up the Data AC UK thing to a national organisation. It's a classic tale of one of my success stories, which has become so important that owners don't trust me with it anymore and give it to people who wear shirts and have meetings. So that's how my project usually succeeds, is everyone goes, yeah, Chris, you've made it too important. We're going to give it to grown-ups now. I'm technically a grown-up, but... Right, so this is a long session. I looked at this for 2 hours. So what I'm going to do is start off with kind of my take on open data. I set up the university open data site, which Ash has spent many years of his life trying to fix since I built it, make it work properly. And then I'm going to talk about RDF, the actual ways of representing it, what it does. That'll be fairly technical, and then we'll have a go at actually writing some RDF for those people who bought laptops. Just a bit of, not a test, more just get your hands dirty, try and write some, get a feel for it. I was thinking take a few minutes break halfway through. Is that one? Yeah, just, I mean, I realised I have to get a drink, this is too long to talk. Alright. Okay. This is something people used a lot when they were first talking about open data, and I actually don't agree with it. I think that closed data is fine. I think that open data and the concept of open data really rubs in the need for private data. But there's really good reasons why you don't put a webcam in your toilet. Humans have an expectation of privacy, they need it to function, so even though open data is great and solves lots of problems, it doesn't mean that all information should be open. Your bank accounts shouldn't be readable by your sister who keeps asking money from you. Your, oh, that's a bit topical. Your personal information shouldn't be available for advertisers to sell you stuff and spam you. Whereas, information from other organisations is really valuable to be open, and once someone's sharing the information, the more easily they share the information, allowing you to use and reuse it, that's just good sense. Okay. Right, so the way I see it is open data isn't so much an exact thing, it's more removing things that make it closed. We did a project with an intern a few years ago who was in a wheelchair, and we were looking at the entrances to buildings. And we were working with him to work out what information we could collect about accessible and non-accessible entrances to buildings, so people in a wheelchair, for example, could work out which entrance to use. And I learned from him that there's no such thing as disabled accessible doors. Because I was saying, that's disabled entrance, that's normal. He's like, no. Because everyone's disabilities are different, so if you're blind, then it really doesn't make much odds if there's good signage. If you're epileptic, then steps don't matter, but strobe lights do. And so there's just factors involved in what allows you to use a door. And in the same way, there's factors involved about what allows you to use data. For me, if you've got a data set, I'd really like it to well-linked RDF with using common vocabularies or failing that change. My dad isn't going to be very happy if he asks for some data from the government and gets it in JSON file. It's useless to him because he's got different skills and expectations to me. Neither is wrong, but it depends on the audience. So, there's lots of things that can stop you using data, and these are kind of the ones I came up with off the top of my head. There's not just, is it available online and can I find it? There's, can I legally use it? Do I trust it? Do other people trust it? So if I use some data from the Daily Mail website, just because I thought it was good, if everyone laughs at me for using that as data, or the White House or whoever's giving out bad data this week, you know, there's a lot of, and that's more of a social constraint as well. There's other people's feelings about it. It's kind of, there's convenience, and for my dad, a web page is most convenient. Maybe a spreadsheet to push. For me, JSON or tab separated values are RDF are far more convenient. So it depends on the person as well again. There's lots of kinds of data, and normally when governments especially talk about open data, they're talking about statistics. The number of deaths in each NHS hospital, the energy efficiency of every government building, the food hygiene certificate is available as open data for every single place in the UK that serves food or drink. Which, fun fact, that is every pub, so it's actually a database of every pub as well, but no one's actually used it as much. I was going to make a choose your own adventure game based on locale and things, but I never finished. I'm not very interested in statistics because I'm rubbish at them. I'm not a data scientist. Whenever I do anything with data to try and learn things, it comes out really bad. I missed the statistics module at A-level and I never really caught up, and whenever I do things, I get laughed at by people who understand statistics. What I find really interesting is simple bits of information that help you. For example, a data set of every room on campus this morning wasn't as useful to me as knowing where this room is. I don't care about all the other rooms, it's great they're there, but I just want to know about one room as conveniently as possible. If I said this data set contains most of the knowledge of the human race and is 50 petabytes, and this data set contains the way you're probably going, and the time and place of your death. You know, like, that one's kind of more interesting, even though there's petabytes in there. So it's not just about quantity, and I find finding the factual information people need and just giving them just enough information when they need it is something that really interests me. From organisations, most organisations have very similar data. We all think we're special, and the University of Southampton might publish a bunch of research data that's very novel, but our list of buildings is pretty much the same as Oxford, except for the fact that Oxford has street addresses and ours sit on campuses. But other than that, they're the same as a university in China, who, I can't remember the name of it now, published their list of buildings using the same schema as we did. Because just because it was in Chinese, the names of the buildings, doesn't mean that the basic structures aren't the same. And I'm really interested in the data about organisations, not just governments. Not many people doing about this yet, but... Right, you've heard of open data, I hope, so there'll be a bit of point of showing you if you haven't. You'll have heard of RDF, and people talk about linked data as well. And a lot of the time, people get these muddled in their head because they're usually used in the same conversations. So I thought I'd go into a bit about what they are. Open data is a principle. It's a way of working. It's saying that we're going to make this information as available to people as we can so that it can be shared, so that it can be reused, so it's about helping people use it. It's a philosophy, a set of guidelines, whereas RDF is a format of data. It's a way to structure information. And there's no guidelines for either right or wrong. It's like XML or spreadsheets. It's a way to structure information. It can be encoded in several different ways, but it's the same information. So there's about 6 different ways to write an RDF document out to disk, but each of them is identical in content, even though one's in XML, one's in JSON, and one's in a language called Cursor. You can write the same information in each of them, and it's exactly the same. And if you do a JPEG or a PNG, it looks the same, but some of the colours are a bit different, whereas in RDF files, they're all encoded as the same thing. Then there's linked data, which is a different again. Linked data is the idea of having web addresses be the IDs of things in the data, so you can go on the web and find out more facts from the existing data, and other people can use the same IDs as you in their data set, so your data is pre-matched, as it were. You remember mashups, where people say data from lots of sources, whereas with RDF, you're using the same IDs as other organisations, so the data links up automatically. Okay. People also talk about big data and get involved with open data because they don't really pay attention. I've heard a lot of leaders and business people and politicians get big data and open data muddled up. Big data and open data, again, they intersect. They're not the same thing automatically, but they can be. Big data is best described as data which is too big, too rapidly changing or download or incoming, or too unstandardized to be processed using classical approaches. So the ways we used to deal with it in computer science, where you just go through it and do a for loop, ain't gonna work. And so big data could also just be described as difficult data. And it's stuff that no one was analysing previously, and there's huge amounts of value in it to analyse, which is why businesses get excited about it. Doesn't mean it's open, doesn't mean it's not open. Actually, the model, I tried to make that a bit more accurate. So, most RDF is open data, and most RDF is linked data. They're not all linked data with RDF. It doesn't really matter. They intersect, but there's a bit of big data that's open data, and so on. Right, why would anyone bother to publish data as open data? And there's some very naive answers, which is pretty much because it's cool, or because our funders told us to. And the one that really pisses me off is that you get some Slacker to write apps for free. There's hacksploitation is a problem. When you pretend you're doing something good for the community and you're actually trying to get idiots to do your work for free. The University of Sydney Opera House, that beautiful opera house, you see a picture of Sydney, they had this competition to write an app for them, which was basically, you're asking us to do a job for you that's worth about £20,000 to £40,000 worth of work, and you're offering a £10,000 prize to the winner. And watch out for that, because it's something, I think a lot of businesses get this idea that if you make open data, someone will just do free work for you. People are beginning to realise that that doesn't work there, fortunately. But there's some better reasons, and I'm interested in trying to make organisations realise why they benefit from publishing open data. People give out open data all the time in non-machine readable forms. They give out data that they want you to have. The obvious one's a business card. It might be shared publicly, but people give you business cards. They want you to have their email address. People give you the menus for their restaurant. Because if they don't, you don't order from them, you order from someone else. And there's real value to those big companies from having their data in your hands. I'm amazed no one's done an XML or some markup format for restaurant menus yet. We've just seen an obvious thing. Right. So, this is a site we created at Southampton with funding from national sources. What this does is it collects open data from universities, and each university publishes a list of their research equipment. About 40 universities contribute, and it was quite shocking to people how we did this, and it was great. Because what you do is you make your information in one of these standard formats, and we looked at what equipment management tools people had, and we accepted decent export formats from those, plus a spreadsheet, plus an RDF format. So the simplest format is a spreadsheet with description and some other fields. And it means if I want to find wind tunnels, if I can spell tunnel, there's some wind tunnels. Nearby wind tunnels. And what's great about this is universities want to be included in this. We're working on making sure there's a stick as well, that if they don't get included, we don't pay, because maybe the taxpayers will give them any more money to buy £1 million piece of equipment. That's really convincing. But actually, just people want to be in this list. They wanted to be included, and I think that's actually quite powerful, that instead of people saying, instead of us trying to convince people to have open data, once it became established, people were really writing to us or ringing us up and saying, why aren't we on there? How do we get added as a colour? And it's actually very simple, and the system runs itself. We've handed this over as well to JISC in the last month or so, and they're going to run it long term. That's a national, it's a charity that's funded by the university sector, so all the universities pay towards it. They also run the network that's called JANET, Joint Academic Network, that connects all the university internet to the internet. So they're the long-term home for this. Right. Oh, that was a slide. So, yeah, these are kind of the cool. We heard it was cool and the next big thing, so we're going to do it. It's not a good reason to do it. And I'm actually much more interested in how open data can actually achieve goals. Most of the work, I think, you look at with governments and things, it's all about how can a business or a person benefit from data published by the government or published by a large organisation, whereas I'm far more interested in trying to convince large and small organisations that they can benefit from sharing data or reuse in a structured form. Everyone has RSS feeds, everyone has web pages. Web pages are practically open data. So the other thing is where we're not collecting information into our site in the normal method, they don't log in and put the information in. We download it from each university's open data. There's a web address with their spreadsheets on. It means that other people can create their own collections based on a different grouping. So instead of saying UK universities, you might have Hampshire research organisations, or European universities, or the Irish Island universities, because if you're in Southern Ireland, it's probably, or even Northern Ireland, then the university in Southern Ireland equipment is probably easier to get to and use than one in mainland Britain. And I've been thinking about what other data sets would be useful to share, not just internally as an organisation, but nationally, so that it'd be quite good if you could, each university publish data about it, and then you collected it up at a national level. The staff expertise, which is the idea of saying that, say, Dr. Smith is an expert in open data, so when a journalist wants an expert in open data, they can research nationally, rather than just trying to use their usual contacts every time. Be good for exposure to the less well-known and early career assets. Vacancies, we do have jobs.ac.uk, but it's, again, the data is created by universities locally, and then they add it to that site as well. So we know if that service could just pull information from universities' websites to that, so we have one less job. And any other jobs agency that wants to advertise our jobs, yay! You know, if a company makes money by republishing our job adverts, it's a bit like a company, you know, when you've made a really, really good video, not video, a TV advert that people think is so funny that it gets replayed on TV shows about funny adverts. You know, And so, you know, you want people to republish certain things. Our publications, the research that we do, we get the quality of our research, part of what it's judged on is how many people reuse it, how many people, when they do research, cite our research as the basis of theirs. So, no one's going to cite it if they haven't heard of it, so the more we can make sure we push the information, the summaries and the full papers into people's consciousness, then. Right. So, the problem with publishing data about an organisation is events. There's a couple of well-established formats. There's iCal and the event. No, the event's the same thing. There's another format that there's a fairly good RDF format for it. Publications listing, bibliographies, data about books and magazines and things. Librarians have been doing this since before you were born. They've been doing it since on computers since before I was born, which is a bit long time ago. I was born before The Simpsons. This is really standardised. And news headlines. RSS is what the classic format. The guy who invented it, one of the guys who's heavily involved in it, sadly committed suicide over an open data related incident. He downloaded a lot of, if I remember correctly, he downloaded a load of research papers he shouldn't have made them online for free and was going to go to jail in America and kill himself, which I'm terrible. But when he was very, very young, like 16 or something, he was working, or even younger, he was working at RSS, and Nick Gibbons was communicating with him about it, because Nick was looking on the same groups, and was horrified as going, it's like, how young was he? Just hadn't realised because the guy was so smart. But those standards are really established. But things for these other ones, for vacancies, for a programme of events, like linking events together with a common theme, like a Star Trek convention or a university timetable. That one I talked about, who's an expert in something, places like buildings, rooms, and things. This is not as well established. There's a good project sponsored by the search engines called schema.org, which has done some work around that, but the frustrating part is all of that is based around what the search engine would want to know, which isn't necessarily for the benefit of you, it's for the benefit of the search engine, and so it's good as far as it goes. And I already mentioned it's maybe not a good one for food menus. One of the problems with all of this is it's fun to model things, and if you've ever sort of got involved in a project where you got a bit carried away and you put too much detail in and you decided to make everything perfect without really being sure why you were doing it, it was just, you know, when you design, I don't know, has anyone ever designed something in a too complicated way? Anyone? If not, you will, it's fun, you get really into it, there's a joy of it, but you also have to spot when you're doing it. Architecture astronauts is the phrase I've heard, when you do such a perfect system that you only ever write 10% of it, and your boss, the person paying you is not happy to have 10% of a really good system, they want 100% of a crap system. Actually, what they really want is 100% of a good system, but there's no hope of that. So I kind of invented this comic book character called the Modeler, who confuses Batman by identifying everything about him. And one of my friends drew that picture. My original one was very, very crappy, done in Biro with a hangover, and this is like a much more artistic one. So one of the things we're looking at is how to define the difference between we've done it and we've done it so other people can use it. So these are sort of the standards that people talk about when they say the difference between we've done it once and it worked for us and other people are reusing it. A few of the things we've done around modelling rooms were based on work that was done by an organisation called Derry in Ireland, and the way that we laid down some best practice for it and how we thought it should be used, and it's been used a little bit. It got used by the University of Oxford, it got used by the University of Lincoln, and it got used by a university in China. That's not really what I'd call success. You know, it's not used by every organisation on earth, which is what I hope. The checking tools is important too. If you've ever used anything for the first time, which we're about to later in the afternoon, you make stupid mistakes. Because not because you're stupid, but just because you haven't learned how to spot them yet. So having tools that can go, oh, you missed a semicolon, is much, much more helpful than having humans have to do it. Because humans are really patronising. And when I first started writing RDF, anytime I made mistakes, there was a guy called Nick Lau, who's still one of my best friends, but he would always just mail me copy and point out all my mistakes. Whereas these days, it's much more useful to do it on a computer and have the computer go, oh, no. So you only make really big mistakes. Yeah, as I said, modelling things can be fun. I love doing it. I like sitting there with a whiteboard trying to work out everything and how it relates to everything else. And there's often a temptation when big ones is to create a model where things can be modelled several different ways, however you want. And that's fine until you try to write a computer program to understand it, then you hate the person who made that design. Sometimes it's you, and you're eating half you. So what... God, I've got three. Okay, so one of the things that's really powerful about open data and linked data is that they can augment each other. So two data sets together are more powerful than either data set by themselves. So those are the parts of the university information infrastructure that we think are the core. This is the core of the university, as it were, informationally. Almost got all of them to being with P at one point. I was going to give products and services and pedagogy for courses, which is a posh word for teaching. But I decided to just give it overforced to make everything a P. Right. So this is a good example of how you can take two data sets and get something out of the two data sets which is more than either data set by itself. This is a website on UK government data. ACUK, or data.gov.uk, sorry, and it's a database, it's a way to download LiDAR data. LiDAR data is created with a plane and a laser, it's cool. And basically the plane flies over an area, usually taking aerial photos as well, and it uses a laser to scan the area, and it knows where the plane was, it knows what angle the laser was, and it can see where the laser glints back. And then it's a big cloud of X, Y, Z coordinates, and processes them a lot. What happens then is you work out the highest and lowest response per square metre. Sometimes with trees and things, you can have two responses. Sometimes with water, you get no response at all because the laser disappeared. But on the whole, you can put together a shape of the area, and then you go, oh, well, that's obviously that building, that's obviously that building, so you can then link those with the real map to stretch any bits that are slightly out and link it to known features. All of England, not UK, England, is available in that format at least 1 metre scale. So every metre of this country, you can get a number of how many metres above sea level it is. It's accessed through this JavaScript website, and the files are a nightmare. When you get a list of downloads for each 10 square kilometres, each download is a zip file that contains up to 100, hopefully 100, files, one per square kilometre. Sometimes not all of them contain all the square kilometres inside, because different planes do different routes. So I've been working with some software that just had to keep going and try another one, no, try another one, no, that's the data. And those files are encoded in a format which geodata people think is easy, and everyone else goes, well, once you actually work out the format, it's not too bad. But it's called a .ASCII file format. Thanks, guys. So Googling for the documentation on the ASCII format is impossible. It's like calling your software download. I like a band called Download. You couldn't find them online or via Google. Download music. No. So these files are in text, and if you can give you a bit of a clue, in the header, then there's 1,000 lines, and each line has 1,000 numbers. That's it. That's just how every metre of that 1,000 by 1,000 metres. Some of them are 2 metres scale, and some of them are 25 centimetre scale, but they're all basically the 1 metre ones are most useful because, you know, I play a lot of Minecraft, and Minecraft 1 metre. Right, so this is a map of the UK Houses of Parliament. It's where our lucky governments meet, and it's quite a distinctive building. But this is the layout of it. You can see the Thames there, the bridge, and Westminster Abbey. And this is OpenStreetMap, which you haven't seen it. OpenStreetMap is to maps what Wikipedia is to encyclopedia. You can go onto OpenStreetMap and you can delete this building, and then a few hours later someone will swear at you and put it back. But it's a bit more hassle to graffiti than Wikipedia, so it doesn't suffer from it in the same way. There's also student groups that volunteers on campus to map regions from aerial data that aren't very well mapped, based on feedback from what Médecins Sans Frontières and some other organisations say they'd like mapped. So here's some data of, I think it was Sudan. Could you find things that look like villages, please? Is that helpful? No one ever died from open data, right? Except maybe in a war zone. I have a friend, actually, who once took small arms fire because of some open data. He was working as a guard on a container ship, and container ships have transponders that tell the world where they are. And these days, when you go around the coast of Africa, and certain parts of Africa, you turn off that. But back then they didn't, so the pirates just went, oh, it's over there, and attacked the ship. And unlike the movie, they fired backwards, and all the pirates went away. The way he tells it was kind of boring, but I get the impression he understates his stories to be terrifying. But someone once told me no one ever got hurt by open data. Is that well? Right. Now this is the LiDAR data that I talked about. This is turning it into an image, and I've used black is 0 meter, black is sea level, and pure white is 255 meters above sea level. And you can see, you can spot the towers. That's Elizabeth Tower, which has the Big Ben bell in it, and you can see the bits of the cathedral, the lumpy bits. And then, even more boring, this is the ground. So someone worked out there's a combination of software and a bit of cues. They use the LiDAR data, they give you the ground height as well. So they remove buildings, remove trees. With trees, you can usually get the laser through them enough to work out what the ground is. For buildings, the software can work out that's a man-made structure and remove it. I'm not quite sure how it works, I've never been involved in it. But given the two things, you can work out how high the building is from the ground. So where it gets more fun is combining these three data sets together. So that is taking the OpenStreetMap data for identifying the buildings, grass and water, and the LiDAR data for the ground height and the top of the features height, and I'm using a popular 3D modelling package called Minecraft. I've got an art project for this half term where I've used this software to create 4 kilometres by 4 kilometres of the centre of the Isle of Wight, and the art centre in the middle of it is challenging the local school children to use it to build their idea of the future or past of that town. So, trying to use open data in an outreach way. Will it work? Never tried it before, don't know, but it doesn't cost very much. Right. Now the nice thing about this software that I wrote is that it doesn't just, well, when I first did it, it was pulling teeth. I had to learn all the file formats were because they're available online. And OpenStreetMap, I can ask for any tile on Earth. I can ask for this map tile for this building. I can work out the latitude, longitude, you do some maths, and you can work out, I want, this is the URL for the picture of this building at this scale. And you can also, for the government data, if you swear enough and make it loop over all the files until it finds a good one, you can make it find the height of this square metre right here. And so the Ordnance Survey, the UK mapping organisation, have a service that lets you turn a postcode into a latitude and longitude. So that programme, that's my childhood address. I don't live there anymore, so I can put it up. That's the address that I grew up as a kid. Whenever I have to put a postcode into something, because I want to use my real one because it's some stupid service that makes me put one in, I use my childhood one so I can remember it next time. And this software goes and it will actually go online, find the map, go online, find the zip files, keep downloading zip files from the government data until it finds one that's actually got the data in, and that's the street I grew up in. And I think there's a huge difference between you can get the data and you can get into the data programmatically. You wouldn't want to download all the LiDAR from the UK. It's not practical. Normally I want the whole data set. I want to play with it all. This is just too big. It would be bigger than most of the hard drive I'm willing to spend out on, and I'd never be able to download it, even on the university network. It would take a ludicrous amount of time. So this is a better solution, but only because I can index it and get into it in a meaningful way. And I think it's the difference between a catalogue of all the data for the trees in the UK and a way to actually say, give me the data for this area. At the moment, councils publish a lot of open data, and it's crap. But every council publishes data on car parks. Mostly it's open data in an XML format. But if you can't find them without searching and using text searches and looking through lists, and when you find them, oh, it's in XML. Yay. I mean, not standardised XML, it's just a random set of fields, it's basically whatever they had lying around. So, it's just not great, and no one has created a standard for car park data yet. They probably have, but, well, that's the problem, there's probably lots, but no standard. Right. See, I really like RDS, but RDS is a really high learning curve, which you're about to do in 20 minutes. But I'm assuming you guys are smart and know about computers and things. But most people find RDS a bit too much of a barrier. I wrote a blog post a few years ago, which was called the Open Data Mullet. Anyone know what a mullet is? It's a popular haircut a few years ago. It's sort of an cliche American haircut with very short at the top and then long at the back, which people use to say sort of business up front, party in the back. And that's kind of what we were talking about for our open data. So we have RDS for people who want to do strict formal open data with good IDs and things, and JSON for people who just want to knock something up in JavaScript for fun. And there's no reason we can't do both. And I think a lot of the time that's the thing. In the same way, if I wanted to do something studying in the UK, it might be really useful to have the 4 terabyte, or however big it is, file for all of that data of England available, maybe via BitTorrent, so I can download it from other sources, from several points at once. But having the big file to download would be really useful, rather than having to write a computer program to download 20,000 small ones. Whereas, for what the project I'm doing, I want to be able to access a small one, but it's not either or, it's data. You can format it in 2 ways, and sometimes the right answer isn't either, it's both. So tabular data is great for normal people. The average person who wants data probably wants to load it into Excel and do a graph or something. That's not what I want. I want something I can load into PHP or Perl. Other people would want to do something different again. So it's about thinking about the audience and doing everything, giving them every option that's easy. And one of the good things most publishing platforms would do is allow you to, what you do is provide some formats so that you do the work for you. So the really simple way of publishing open data is you get some data, you add some metadata like a title, a date, copyright, and you put it into a database like YouTube for data. What we do is a bit more complicated. We take the data from one of several sources, we push it through a conversion tool that we wrote to create RDS, and then we publish that. The value of this is, where, for example, the university changes its buildings quite regularly, you think buildings don't change, but every year, every 3 months or so, the university adds or demolishes the building. So we actually do have to rebuild the data set of buildings very regularly. So at that point, we can't just once polish the data, get it clean, get it right, push it over. What in open data circles is sometimes called throw it over the fence. You know, we've done it. Happy now? Right, get on with our real life, real jobs. And so we've got maybe part of our flow rather than something we do once. And where those tools produce RDS, it's quite easy to make them produce more than one format and keep those formats up to date. We also dump the RDS into what's called a Sparkle graph database. Anyone know what Sparkle is yet? Stephanie does know, that's reassuring. Okay, so Sparkle is a querying language for querying a big pile of RDS data. We've got sparkle.data.southampton, which Ash will probably tell you a bit about next week. You can play with that one. There's other Sparkle databases available openly online. There's one linked to Wikipedia data, which is pretty cool. And it's how you can query small amounts of information to big database. We use our Sparkle database to produce public individual pages of data, and we use that to mostly power a lot of the application that built on top of open data, which Ash will be talking about next week. And we have a URI. Does everyone know what a URI is yet? No? Okay, right. Everyone know what a URL is, please? Anyone not know what a URL is?
Yeah.
Okay, a URL is the way you locate something on the web. It usually starts with HTTP, but it doesn't have to. It can start with Mail2 or FTP or Gopher if you're really old. And it's the way to locate a resource on the web. A URI is the superset of that. It indicates the resource, but it doesn't necessarily locate it. So you can have a URI for the colour red. You can't get the colour red on the web because it's a colour, it's not a digital document. But you can talk about the colour red, but you can also get a URI for my homepage, which is also the URL for my homepage. And in RDF we use URIs to identify things, and when you go to one of our URIs through a web browser or using a web connection, our URI resolver works out what you're asking for and goes, can't have that, but I'll give you a page about that. So you've seen 404 not found and 403 forbidden and 200 okay. Claim to fame, I once gave Tim Berners-Lee some women's panties with those printed on. I thought it was really shocking because I bought for there's these 200 okay panties that things were selling, and I was like, wow, I was going to throw them on stage, but I thought Wendy Hall would kill me. So it was in the lobby of the Royal Society. I don't think you probably remember this, but there was also full 1 step, I think, for the rest of the. But anyway, 303 was the point of this. Sorry, 303 is see also or see other. So when you do 301, it means that's moved to here forever. And so 302 means, that's temporarily over here, but it might be somewhere else later. So don't just update your bookmarks. Keep asking the original one, but it's temporarily moved. 303 means, yeah, what you've asked for, I can't give you. I'll give you this other thing, which is useful for the web, for semantically aware browsers, because they know what they've got back isn't identified by the thing they asked for. It's a document about the thing they asked for. If this turns out to have not been a good design, and there's been years trying to get a better one, because it confuses lots of systems, get the identifier and the location muddled, and we probably shouldn't have merged them. That was a mistake in the design of the web. Don't tell us that Tim I said that. Okay. This is really frustrating. When we've done loads of really good work or something, we put the data out there, and we hired an intern for the summer, who's a final year student, who, when he had a look at some of our data, and he's a really keen programmer and interested in this kind of thing, he was like, oh, this is really good. I'm like, oh, you've been there since you were in our first year, and you never knew about it, and you're a target audience. And we have real trouble working out how to promote this. Unlike the government, we're not very big, we have limited resources. I mean, the government open data has fairly limited resources, but it's just how to work out how to communicate things. If everyone did open data, you'd be banging our door down saying, where is it? You know, we need data for where the Pokestops are, or we need data for where water fountains are, why aren't you providing it? But it's not like that yet, and hopefully one day it will be. It'll be, if you don't get open data from your university, it should be shocking as us, not providing Wi-Fi, but we're not there yet. So, this is what we were told. This is the real pitch, that if we built open data and just published it, people would use it for things. Not what actually happened. It works for government, and even a lot of government open data doesn't get used because people either don't know how to use it. It fails one of the things that have stopped people using it. One of the ways it's closed is a deal breaker. So, what I was looking at here is a thing called hygiene factors. Anyone heard the term hygiene factors? So this is a concept that I got in. I once thought I wanted to get promoted and did some management training, but I never really did the management afterwards. So in my management training, they talk about hygiene factors and why people stay in a job. And a hygiene factor is something which, it doesn't matter how good it is, it matters how bad it is. And so, for example, volume of noise at work. If your workspace is absolutely silent, doesn't really matter. If your workspace is quiet enough, that's fine, and it doesn't make any difference between quiet enough and perfectly silent. But too loud is bad. And it doesn't matter how good your everything else about your working environment is, if it's so loud you can't do your job, it's crap. And nothing else, you can't make up for it, you have to fix it. And it's called a hygiene factor because any It's a bit like washing your hands. If you go to a restaurant and this restaurant's losing business because they clean the floors really well, but they never wash up the dishes. They just reuse dirty dishes, and you can see someone else's lunch on it. And you complain about the place being dirty, so they double the amount they wash the floors. And this is what a lot of us do when we're publishing data. We do the bit we're really good at even more, and we completely have missed the fact that, or we've forgotten to ensure that the staff wash their hands in the restaurant. And so you wouldn't eat there even if the food was great, because they don't wash their hands. And no matter what else they do, no matter how good it is, that's the one thing that puts you off. So we made this list of factors which kind of multiply together, and if one is perfect and 0 is terrible, they all have to be okay. And if any of them are 0, you're screwed. It doesn't matter how good everything else is, anything is bad. And when I did this, and we had a meeting about why people weren't using our open data, it turned out I missed one. And my manager, pointed out at the meeting that one of the reasons other parts of the university weren't using our data set was because they didn't perceive it as reliable. They saw our project as sort of a bonus project that they would get in trouble for relying on. So this is and everyone's blind to the thing they're doing wrong, so it took someone else looking at what we were doing. So I'm a bit embarrassed about this one, but there's bound to be other things we haven't thought of, and I can't tell you what they are because I haven't thought of them. Known unknowns and unknown unknowns. So all of these things, it's important. They're all important, and that's something I think we really fail on ourselves. Is we work really hard on one of them and we do it perfectly, and we go into that kind of architect strategy role, and then we don't have enough time to do all of them well, and so we let some of them slide, and we're trying not to, but it's hard. Right, so here's a list of just some good sources of open data. Hampshire Hub has data about the local region. Data.gov.uk is a catalogue of council and government data. Data.southampton.ac.uk is obviously about the university and should be fun for you to look at. Data.io used to be called something else, ccan.net, and that's just a big international database of open data-y things. And Salt City Data was an experiment I did to try and collect up data sets that covered Southampton and make a catalogue of them, but no one really cared, so I didn't get very excited about it. It's not very good. Right. I suggest take a little bit of a comfort break now, and afterwards I'm going to talk a bit about RDF, and then we're going to write some RDF, if you've got laptops, or snuggle up somebody, sit next to somebody there.
So we get 10 minutes, come back at 1 o'clock, okay?
有点热啊，又困又热。他说你什么时候下课啊？他说什么时候？哎，我不用讲电话。对呀。他昨天上午去了吗？那个去了吧？好像没去。对呀，好像没去吧？没去，为啥不去了？有种小鸡鸡。